Okay, so now we're going to look at using assemblies to assist us with manufacturing processes. So we're going to look at a brake rotor as the example. We can quickly go through the instructions real quick as to what we are going to be doing. So first we want to have a casted part, and that's what the goal of this is, for us to take a casted part that is not finished, it has not been machined, it's just a fresh casting, and we want to machine it so that we have a finished product. What we want to do is we want to design those machining processes in the assembly. So we're going to design the finished part, and we're going to do it sort of like as if we were in the shop machining this. This is helpful for a few reasons that we'll talk about here in a second. So the first one that we want to do is we want to make sure that we have a casting. You can download that here or at the bottom. It's also there. Then we want to create an assembly file, and the assembly file is going to be the actual machined part, slightly different from what we have been doing before. So if we were to do this with the methods we've used before, we would have a machined brake rotor and then the casting, but we would have two separate parts. We're not going to have that. The assembly itself is going to be the finished rotor. And this is helpful because anytime that we use that rotor anywhere, the casting is also a part of it. And so we always know that in order to have this finished brake rotor, we also have to have a casting. We can't just have the machined rotor without the casting. So that's the way we're going to be doing this. So we're going to create an assembly file, and then we're going to add the casting to that assembly. So we're going to add that component into the assembly. We are going to link the body. We're going to essentially make a copy of the body of the casting, and then we are going to be using that copy to machine away those components. So we're going to have two separate bodies in the assembly, but only one component is added, and that's the casting. So the parts that are going to be machined are on canvas. We want to machine away the sections here that the brake calipers, the brake pads will be contacting, and then we want to finish the overall height here. We want the overall height to be 1.25. And then also we want to drill these holes. So these holes are 0.18 inches in diameter. There are 4 of them in this arc right here. And then there are 10 sets of these, and they are equally spaced around the rotor. We're not given dimensions on the location of these. What we're told is that they have to be placed in between the internal fins, and they need to be equally spaced around the rotor. So we'll make some adjustments here when we come to make those. So the reasons that we are using this process, one of the ones we've already mentioned is the fact that the casting is always going to be part of the finished product. And so it's always going to be part of the bill of materials. It's always going to be something that we know that we need. The other reason that this is nice is that we can then take this as a starting point, and we can make different iterations of this brake rotor. So maybe instead of we have a model that has 4 holes, maybe we have a model that has 3 holes, maybe we have a model that has more than 10. But we can take this and as a starting point and have different iterations of this model. So we don't have to start fresh for every single model that we have. We can just take this and make changes as we go. So maybe there is a more advanced model of this where we have, instead of 10, we have 12 or 20 or whatever sets of these holes. But we're not starting fresh with that. We can just start from this model. So let's go ahead and open up NX and get started. All right, so when NX opens up, first thing that we want to do is add a component. And the component that we want to add is the casting. We'll go ahead and hit OK. It'll ask us if we want to add a fixed constraint. Say yeah. And now this is our casting. So this is the brake rotor before it's been machined. So we still have excess material on here that needs to be taken off. And what we're going to do is we are going to essentially copy this body, and then we are going to remove material from that copied body, and that will be our brake rotor, our machine brake rotor. So this is different from the other assemblies that we've done because we're actually going to be creating sketches and extrudes in the assembly, but it's not going to be on a component. So when we made the engine mount, we were working on that engine mount in the assembly. That's not what we're doing here. We're not working on a separate component. The component that we're working on is the assembly. And when we think about the difference between an assembly and a model, it's still a part file. The only difference is just how we're using it. And so we have the casting. Now we want to copy this so that we have our brake rotor that we can actually machine. And the way that we're going to do that is to make sure that we have our assembly as our work part. And we're going to go to Wave Geometry Linker. Make sure we are in body. And we're going to select our casting. Sure associative is checkmarked. Fix it current timestamp is not checkmarked. And we'll hit OK. And it looks like nothing happened at all. But if I hover over this, now it looks really funky. It's because there's two solid bodies here, and the solid bodies are the exact same. So this is NX's way of kind of showing both of them at the same time. If we look at our assembly navigator, nothing's changed because we technically only have one component that we've added, but we have two solid bodies. So I'm going to turn off the casting. I'm going to hide the casting. And you see we still have a solid body here. This is our linked body. And if we go to our part navigator, we can see our linked body. So this is one solid body, and our casting is our second solid body. So just to make sure that I don't get confused and accidentally machine the casting, I'm going to change the color of the linked body. So I'm going to go to View, Edit Object Display, select this is the linked body. Select this. And I'm just going to change the color of it. So now this is our linked body. This is the part that we're going to machine. And this is our casting. The gray part is the casting. The blue one is what we are going to machine. And I'm going to keep the casting hidden because we don't really need it anymore. From here on out, we're just going to be working on the machined rotor. So if you look at the drawings that are on Canvas, we are going to be machining away the very top, this top surface, and the bottom surface. But we are referencing a mid-plane that is between this top surface and this bottom surface. So that is the first thing that I'm going to do. Go to Home. I want to add a plane. It's going to be a bisector. And I will click on this top surface here and then this bottom surface. Remember, the bisector planes take two faces, and insert the plane between those two faces. And now we want to be able to remove the material. So we're going to be sketching a little bit differently than we typically do, because we already have the solid body. We want to remove material from the solid body. We're still going to make a sketch. So let's make a sketch. And I'm going to sketch on this top plane. So this is the plane that is splitting the brake rotor in half. The right plane would also work here, but I'm going to do the top. So we have material down here to remove, material here and here to remove. Let's start at the bottom. So I'm going to create a rectangle, and I'm going to start on that axis, and I'm just going to come over and put the rectangle down. And the rectangle, we're told the top machine surface, or the machine surface here on the bottom, the top of it is 0.34 inches from this, the plane that we created. And so I'm going to dimension that from the top of this rectangle to the plane. But I can't access it right now because of my filters. So if I change my filter to within work part only or entire assembly, I can now access that datum plane. And so I'll put in a dimension of 0.35. And this is the material that we want to remove. So we want to define this boundary in a way that when we revolve this, we subtract this material. But we can't just let this rectangle look like this. We have 4 undefined curves. So what I want to say is from this bottom edge here to this rectangle, I want to be able to put in a dimension there, but you see it's not letting me do it. So one thing that we can do, this is the process that we're going to use, is we can project that curve. So I'm going to come over here to More, Project Curve. And I'm going to select that line right there. And that is going to project that geometry into our drawing. So now I can select that and change this to, let's say, 1/4 of an inch. Same thing here. We want to define this box so that it goes beyond the edge of our brake rotor. But we want to be able to actually give it a dimension so that we have a fully defined rectangle. So again, we're going to project curve, and I'm just going to do this curve here. And now from this end point, from the start point to the line, we can say again, we'll say again 0.25. So now we have a fully defined rectangle that when we revolve this around this axis, we will remove all that material at the on the bottom of the brake rotor. But while we're still in this sketch, we're going to go ahead and remove the rest of the material as well. So we're going to move material at the top and the top of the where the brake pad makes contact. And I'm going to go, so to create this, I'm going to go to Profile and just kind of roughly sketch in the shape. We're going to go over and then down, over again, up, and then back over. I'm going to extend that, and then I'll make a corner. Now we have a 2D boundary. And I'm going to start adding the dimensions that we know. So the first thing that we know is that from this machined edge, so this line right here is where the bottom of the machined edge is going to be for our rotor. And we know that from this edge to where the top of the machine part is going to be 0.7. So from this edge to that edge, it's going to be 0.7. We're also told that from the bottom edge to the top of the brake rotor is 1.25. And so that's the basic. So we're removing that material and that material. Now we need to define the rest of this shape so that it's fully defined. Since we've already dimensioned this 0.25, I'm going to create I'm going to do a collinear constraint between this line and that line. And so now those two lines are going to be on the same axis. The top line here, we're going to do the same thing that we did as at the bottom. So I'm going to project curve. I'm going to project this top line, and I'll dimension from that line to the top of that box, do 0.25. And this line that's projected is just the top of the rotor. And then you see we still have three movable curves. That's this curve, and this curve here. So really it's this length that right here. And we don't have a real good way of defining this like we'd have done with the top and the bottom. But if we tilt up, we can see that this top surface rounds down, and then there's this transition fillet to the top up here. And what we want to do is we want to project this line so that we can line it up with the edge of our box. So we'll come up to project curve, and we're going to do this line. So it's the line before the bottom one. So we're going to project that. And what we want is for our endpoint, we want to do a vertical constraint for the endpoint of the line and that endpoint there. Say okay, and now that's going to be made vertical. So those 2 points are on the same vertical axis. Our sketch is fully defined. But before we finish the sketch and go and revolve this, we need to take all of our lines that we did project curve with. We need to turn those into reference lines because they're not going to be used for any geometry. They're just used for reference. I think that's all of them. Looks like it is. Sketch is fully defined, so we can finish. And with those sketches still selected, I'm going to go to revolve. Yep, curves are selected. I'm going to specify the vector. I'm just going to choose this inside circle, so it's going to choose the axis of that. Revolve 360, we're going to subtract. We can hit OK. And now we have the machined bottom surface, the machined top surface, and we've changed the overall thickness of the brake rotor. Now we need to go in and make the holes. We have 10 sets of the 4 holes. We want to create a sketch. We want our sketch to be on the top surface of the brake rotor. We'll hit OK. And we need to position our holes between the internal fins. We can't really see them right now. So what I'm going to do is I'm going to go to View, and I'm going to change into Static Wireframe. Now we can see those internal fins. So our holes need to be between these fins. So I'm going to go back to Home, and I want to project these curves into our sketch. And I'll go to More, or I'll go to More, Project Curve, and we will select Curves, hit OK. So our holes need to follow between these 2 curves. And we're told that the first hole is 0.375 inches in from the internal, from this diameter here, and then it's 0.37 from this outer diameter. So I'm going to go to Offset, and I want to offset this curve in 0.375. But I can't select it because I'm within Active Sketch only. So if I go to within the part, then I can access that curve. And this is the one that we want, the one that's closest to our slot. So we'll select that. And we have 0.375. It's in the right direction. So we'll hit Apply. And then we want to come out to, again, the line that is closest to our slot. We want to change the direction so that we're going in. Still 0.375. This time we'll hit OK. So the whole point here is that because we want to be able to create, we want to create our line that follows the same radius as our slots here. And we want our holes to be 0.375 inches inward on both sides. Now, we don't need all of the lines here. We really just need that between these 2 projected lines. I'll come to Trim, and I'm just going to trim away those excess lines. Then I'll come over here to the arc, and I want to select the midpoint. So I'm going to take off the point on the curve. And now it should snap to the midpoint. Same thing over here. I want to snap to the midpoint right there. And I'm just going to put this somewhere where it's not going to put an auto constraint on there for us. Now it looks like the 2 curves that we have down here are the same radius, but they're slightly different. We are going to use the one that's at the bottom. So we're going to choose the curve that's at the bottom. So we're going to come here to make equal, make sure that we have equal radius, and we're going to say that we want those radii to be equal. We'll hit OK. We have sketches fully defined, and you might think that we would come up here to point and start putting our points in, and we could make that work. But there's an easier way to put these points in. Remember, they need to be equally spaced along this line, and that's why we've gone through the effort to create this line this way, is because we're going to have a point at both ends, and then we'll have 2 points in the middle here, equally spaced. So we're going to go ahead and finish this sketch. I'm going to change our view back to shaded with edges. We're going to come over here to curve, and then point, and point set. We want curve points by equal arc length. And we're going to select that arc that's in the center, the one that we created. And we want number of points to be 4, start percentage to be 0, and then end percentage to be 100. So we are distributing 4 points along 100% of this curve. So we can hit OK. Now we have our 4 points for our holes. Now we can go back to the home. We can go to the hole command. We want a simple hole. This is going to be 0.18 inches in diameter. No start or end chamfer. And when we go to specify our points, we're actually going to come over here to the part navigator and just select our point set. That's going to select all 4 of the points for us. Make sure that we have a through body. And we're subtracting, and we can hit OK. So the through body is going to actually go through both sides of this brake rotor. So we have the set of 4. Now we need the 10 sets all the way around. So we want a pattern feature. We want a circular pattern feature, and when we go to the select the feature, we want to select all of our holes. The vector that we want to select is the center of the brake rotor. We want a count and span, so a count of 10 and a span of 360 degrees. So we want 10 of these, and we want all the way around. Well, let's say show results just to make sure. That looks right, so I'll go ahead and hit OK. And then I'm going to take us back into static wireframe. We can make sure that we're not breaking into any of the internal fins. And that looks right. Next, we'll change our layers. And now we have our finished brake rotor. Now remember, we still have our casting here. And then that's our finished brake rotor. So make sure to submit this to the Dropbox on Canvas. I don't need to send in the casting part file as well. I have that, so I'll be able to open up the assembly. And that's it for this one.